So I have a formation in physics. I studied physics in Italy, in L'Aquila. It became famous for the earthquake. There was a strong earthquake in 2009 in L'Aquila, unfortunately. I did my master there and also my PhD in L'Aquila, always in physics, astroparticle physics. Then I moved to Germany. In Germany, I did 3 years of research in physics, and then I moved to data science. The transition was quite, I would say, quite smooth, because I was already using during my PhD and postdoc many techniques that can be applied to machine learning, such as neural network or other algorithms like the classical one that we use for. So the transition in Germany was, I would say, quite smooth. At that time, during the transition, I was also looking for a job in Italy during this transition phase, but the transition was more or less impossible in Italy at that time, because I think in Italy there is still this situation in which the industry does not trust so much people that come from academia. I don't know why. While in Germany, I would say it's the opposite. So
the opposite. Yes.
Yeah, it was an easy transition. I mean, in Germany, I know that many people do the PhD without any ambition of doing academic career. They do the PhD just to have a better position in the industries. So then I worked for 2.5 years in a startup in Berlin. The startup was focused on artificial intelligence, particularly on a way of doing machine learning that's called federated learning. So it's distributed learning. It's learning from different sources of data without compromising the privacy. This is particularly useful for industries that want to collaborate each other without sharing any kind of private data. So it's there were a lot of, for example, pharma companies collaborating with us because they have interest in collaborating to create new drugs or new vaccines, but federated learning allows this collaboration without compromission of privacy. And then I got in 2023, I got an offer from GSK, GlaxoSmithKline, is a big pharma company that it's, I would say, everywhere in the world, and it's also in Italy, in Siena, Parma, I think also Verona. I got the offer from the research center here in Siena, in which I'm now working as a senior data scientist. My main topic here is to apply machine learning algorithm to age research. So, for example, natural language processing applied to DNA sequences, or also deep learning for image recognition. Deep learning in general.
I see.
And that's what I'm doing now.
So what prompted you to change from astrophysics to data science?
The academic world is very unstable. So being a permanent job, you really need to do, let's say, 1 PhD, at least 2 postdocs after the PhD. Each postdoc is, let's say, 3 years. Most likely you have to relocate for each new postdoc. And at some point I was really stressed by this life. I also got a child during that period in Germany. So that's why I decided to go for a more stable job. There was also, I would say, a boom of position in data science and artificial intelligence in 2020 in Germany. Many startups arrived in Berlin, so that's why I've decided to do this transition. Many colleagues were doing the same. So at the beginning, I was a bit skeptical. Then, I mean, the transition, in my case, it was very smooth. It just changed the field of application, but I was basically using the same tools that I was using before. So Python for coding and the same machine learning algorithm. So it's just a shift of field in which I was applying my knowledge. But
it's quite smooth and easy.
Yeah, in Germany, I would say yes. But I know that other people, some friends or colleagues, tried to do the same in Italy, and in Italy it was very hard.
Why is it hard?
It's like, I think industries, there is no cooperation in Italy up to now between universities and industries. This is my impression. So the PhD title is seen as something very related to academia, and industries do not trust or do not recognize this title as some added value also for working in industries. This is my impression. So it's much more easier in Italy. If you go abroad, you work, like in my case in Germany, you do the transition and then you want to get back. If you want to come back when you have already done the transition, then you find many open doors. But the transition here, I don't know. But now something is changing, because I've seen also in universities here in Italy there are new faculties of data science related. So there will be people with master's degree in data science. This will facilitate, of course, their path into the job.
I do notice that you're also publishing papers.
Yes, because I'm working in the R&D, so it's the research and development department of the industry. Just recently we got accepted the paper. Probably it will appear this month. If it appears, I can present something also at the conference. And this paper was on natural language processing applied to DNA sequences. It's quite funny that you can use the same techniques that you use for analyzing human written text. So it's exactly the same, like the famous Twitter sentiment analysis. You apply in that case the natural language processing, so you convert text into numbers and then you analyze the sentiment of people that are writing the Twitters, and you can apply exactly the same techniques to DNA sequences, because at the end it's a text, it's a sequence of letters. It's just not understandable by a human, but it's for the machine is a text anyway.
Is there anything that cannot be converted into number at all?
I would say yes, but there are also now modern techniques that use the graph neural networks, for example. Also, there are new modern algorithms that can manage categorical feature text directly. So while I would say until a few years ago it was necessary to convert everything into a text matrix, into a numeric matrix, sorry, now all these algorithms are becoming more and more general, so able to take more or less everything as input. I'm not a biologist at all. I don't know anything about biology, but I see that there are colleagues working on the structures of proteins, and in that case, they do not convert the structure into numbers. They use an algorithm like the reinforcement learning, in which there is a sort of the reinforcement learning was born with game theory. So it's a type of machine learning in which you do some action and then you don't have the rewards, and so the algorithm is able to learn autonomously with a series of rules and rewards. For the structure of proteins, for example, this is the way that it is used, and there is a famous algorithm that is called AlphaFold. So it's probably Google AlphaFold, that uses this technique.
I feel like if it has alpha in the front, it's somehow related to Google.
Yeah, when there is because there was also AlphaZero, that is the chess.
AlphaGo.
AlphaGo for Go, yes. I'd like to also discuss with Alessandro Ferrari to discuss about various things, in which way the AI evolved in the last year. So starting from what we had in the 90s, because it's funny to notice that the theory that we are using today for deep learning, it was written in the 40 years ago. So the theory basically did not change. We had already the theory ready, then there were different waves of AI, but the problem was the technology. We did not have a sufficient technology to train such a powerful algorithm. So then in the last 10 years, we had technology. So the dramatic change was especially with this the video card by NVIDIA, the GPU, because at that point we were able to train neural networks with millions of parameters. Now we can even train 10 to the 9 or more parameters. And so I want to focus on this evolution and how we started from the theory of 40 years ago to the modern algorithms, going also to arriving to ChatGPT and all the modern tools. I will focus for sure on the things that I'm doing, so natural language processing and deep learning, but I will present, of course, something related to that, but I also want to do a bit of history of how we arrived to this algorithm.
You are still deciding on the title, let's say.
Title, okay, yes, the title I will give you. I will send you the title. I think I was involved in neural network very early when I was doing my master's degree in physics. For the first time, it was 2010, and I did my bachelor degree, my bachelor thesis in neural network. At that time, it was very unusual. I used neural network to model a machine that it's necessary to create semiconductors like silicon. Since it's a machine with a lot of parameters and we wanted to evaluate the performance given the parameters, was this idea one of my professors told me, okay, why you don't use this algorithm? It's called neural network. So I started to study that. I remember the commission was quite skeptical about that. There was a huge division in my bachelor thesis because someone said, okay, but this is too exotic, it will never fly, and there was another professor that said in 10 years we will do everything with neural network. So now we know which one was right. I think there is a huge potential. I would say it's not completely used 100% because the boom was quite recent. I think another wave of boom started with ChatGPT last year. So we are still in the phase in which we need to understand what we can do and how powerful it is. But I think for many tasks there will be a huge acceleration. ChatGPT, for example, can be very useful in doing all the boring stuff that personally I never want to do, like summarize things or create a structure for the slides or I don't know, things like that. Then of course we can think to much more advanced things, like it's very useful for us to have a series of papers in which we want to extract information. For example, in the field of vaccine, I think I don't know which antigen are useful against a certain disease. And up to now we have always done this screening manually. It's a huge amount of work. It takes a lot, of course, if you want to screen hundreds of papers. And now you can do that with these large language models in few minutes. So you just provide some papers and you summarize most relevant things. So this will be a huge advantage. I don't think in the current status this algorithm can do discovery alone. So they are not able to invent new things, or maybe they invent things, but they are simply wrong. So if you ask, for example, for references to a scientific paper to ChatGPT, it will give a lot of references. 90% of the references do not exist. So are just invented from scratch by the algorithm. So we need a bit to understand how can we use these powerful tools, but also the things that they cannot do, because they are done in a way that they always will give an answer. It's rare that they say, I don't know the answer, I cannot answer. The large language models are structured in a way that they always will try to say something. So we need to understand when they can give an answer, when they cannot give an answer.
Do you feel like the user needs to have certain capacity to fact check the AI tool?
I think yes, but this was already true before ChatGPT, because also in let's say more standard machine learning algorithm, you always need to understand if the algorithm is able to generalize to unseen data. The major problem usually with machine learning is that you create the algorithms, is performed very well on the training data, then you test, it's okay, the performance is a bit lower, then new data arrives and the performance goes down dramatically. So this is something that you always need to be under control of the data scientist or machine learning engineer. So now it's just another step with the large language models in which you need a bit more fact checked, but I would say this was already present before. It did not change so much. There are a lot of physics that are doing data science now. We are really a lot. I think the reason is that usually for data science you need to know at least three things. You need to code, and we do a lot of coding during the physics study. You need to know quite well mathematical statistics, and you also need a bit of problem-solving attitude. So those are the three things that are necessary for doing data science, and that's why probably physicists, but also people from mathematics, statistics are there are many of them in data science. The most important difference from my point of view is that usually when you do research in physics, you write a code for yourself. So you write the code for publishing the paper, and then that code will never be used anymore unless you do similar things and you reshape the code in some way. When you join a data science team, and this was particularly relevant in the startup, you start coding together with other people. So you recognize immediately that you need a different style, the style that we call the production level code, in which you also learn how to write good codes, and you also learn how to use GitHub, how to share your knowledge, and how to code together with other people. So I think this is the most important difference between academia and industry work as data scientist.
I see. We put aside that difference between academia and industry. On the personal level, do they have any distinct difference from each other?
Yeah, I think it's a very different career, yes. It's very different because I would say at some point the two paths are completely separated. So when you continue in academia with postdoc and then professor, etc., at some point you start making lectures, teaching, you are not active anymore so much in doing your stuff in coding or in creating new things. It's more work as supervisor and professor in teaching the others. In the industry, what I'm doing now and what I prefer to do is more to have hands on the problems. So not just delegate other people. I want to be active in what I'm doing, and I think this is the biggest difference.
In academia, people will be more retrospective, more looking back, whereas in industry, always looking for change and progress.
You are forced to do that because at some point in academia, you less time to do research because you have to do lectures, you have to do university courses, so you cannot be so active anymore in research. Of course, you will have PhD students, you will have master students, but now all the things for AI, for example, the biggest research in AI are done, from my point of view, in industries. So it's Google, it's Meta, it's Amazon. They are really pushing for the research in this field. The takeaway will be that machine learning and artificial intelligence in general is really, really universal, and it can be applied to whatever field. Because I will show different examples, starting from physics, going to distributed learning, going to biology, in which the same techniques are applied to completely different fields. And in principle, this should be the real role of data scientists. So the data scientist should not be an expert on a particular field. It should be expert on the data analysis, on machine learning, on statistics, but a true data scientist in a true data science position should be able to work in wherever, in a bank, in a automotive industry, in a pharma company, because all the techniques are very, very general and can be applied to whatever kind of data. Seeing the names, I'm very happy to join because there are people that I know only virtual via LinkedIn, let's say, and many people very expert in AI. I appreciate the publications, their posts, so it will be very nice to be there in person and to know all these people. I like these events in person because we were too much now probably addicted to this virtual stuff during the pandemic, so it's good sometimes to have also meeting in person, because especially when you are doing some research, many ideas really come while you are taking the coffee at the machine, and it's not rare. It's quite frequent that you just talk with people randomly and some ideas come in your mind.
I see. Want to make sure that you don't arrive too late in Pavia.
Yeah, let's say 4.
Yes.
Yeah, because Siena is connected very bad, because I have to go to Florence. A good train from Siena to Florence, it takes 1.5 hours to do a very short path. Then there is the Firenze to Milano, and then Milano Pavia, so it takes 5 hours, and I will lose half of the event in this way. Friday would be better.
I feel your pain deeply because from India to Milan was supposed to be easy peasy, but it
Yeah.
was not.
But it was
It
not.
was not. I remember mushroom and cheese.
Yeah, I just don't like. I can eat. I will not die if I eat them, but I don't like.
Ah, I see. Oh, well, anyway, mushroom out, cheese out.
Yes.
We can live without mushroom for one day.
Yeah. Thank
So,
you very much. Let's stay in touch. Okay.
thank you
Bye.
so much. Have a nice day and a nice weekend. Bye
Yeah.
bye.
See you. Bye.